In this part 3 of solving systems of linear equations by substitution, this is going to be the most tricky problem you come across, okay? We have two equations that make up the system of equations, y equals 3x minus 13, and 3x plus 2y equals 19. We know that when we solve a system of linear equations, that means we have to find the values of the variables in the equation. So we're looking for y and we're looking for x, right? We're finding the point of intersection. We know that the y's and x values are going to be the same in both equations. Okay, you're going to begin by solving for a variable in either equation. All right. The easiest way would be to see that y is already solved for up here. We know that y equals 3x minus 13. Therefore, we're going to use this first equation to help us solve the system. We know that y equals 3x minus 13. So, what we're going to do is we're going to plug this whole part into our y value down here. Okay, so let's recopy our second equation that we're going to use. 3x plus 2y equals 19. And we know that y is equal to 3x minus 13, so let's plug that in. Okay, 3x plus 2, put your parentheses in because you have to copy this whole thing here. 3x minus 13 equals 19. Okay. We have to use the distributive property here. All right, in this case, we're going to have to distribute this 2 to the 3x and also to the minus 13. All right, let's further simplify this side of the equation. We have 3x plus, well, what's 2 times 3x? 6x. Minus, right, you're keeping your minus sign, and 2 times 13. 26 equals 19. All right, we're not finished solving yet, right? We're looking for x now. We already know what y is up there. All right, we plugged in for y. Now, we don't know the exact value of y yet. We don't know the numerical value. But down here, we're looking for x. We can further simplify. We can combine these like terms here. 3x plus 6x is 9x. Minus 26 equals 19. All right. Again, we're trying to isolate the variable or get it by itself, so we want to do the inverse operation to get rid of this minus 26. We're going to add 26 to both sides. These cancel out and we're left with 9x over here equals 45. Right, 19 plus 26 is 45. All right, we have to get x by itself. Doing the inverse operation, we're going to divide by 9 on both sides. These cancel out and we're left with x equals 5. All right, we just solved for x. Now that we know the value for x, if x equals 5, we can now plug it back in to our equation up here. We know that y equals 3x minus 13. And we know the value, the actual numerical value for x now. So we're going to plug that in. Okay, so let me recopy this equation here. Down here, y equals 3x minus 13. We know that x equals 5, so let's plug this in right there. Y equals 3 times 5 minus 13. Y equals 15 minus 13. So y equals 2. We found the value, the numerical value, for both our values, or sorry, yes, for both our variables, x and y. So now, let me write that in ordered pair, 5, comma 2, right? Because our ordered pair is made up of an x, comma y. So here is the solution to the system of equations. That's the point of intersection.